Hello guys, and welcome to this new Python tutorial. Today we are going to talk about inheritance in Python. Inheritance allows us to define a class which has the capability to inherit all the methods and properties from another class. The class that is being inherited from is called the base or parent class. The new class is called derived or child class. To understand that, we can start from an example. First, we can define a class which is called employee. We can add a docstring that says this is a class to define an employee in a company, for example, and we define our constructor. So write def init, we have self, and we add a list of skills. So we call that skills list. We set self dot skills list equals to skills list, and for example we define a method that says if, for example, this employee is a data scientist or not a data scientist. To do that, for example, we can write if is data scientist, or let's say analyst, write the self, and we define our data analyst skills. So we have data analyst skills. For example, we can write we have R, for example, we have SAS, we have, for example, Python, for example, statistics, okay. We can add, for example, calculus, we can add linear algebra, for example, we can add SQL or no SQL. We can add, for example, data cleaning, so data cleaning, for example, data visualization, okay. So for example, we define our data analyst skills and we add another list. For example, we call it comparison, okay. So for skill in self dot skills list, so if the skill is in our data analyst skills, so we append that to the comparison list. So we write comparison dot append skill, okay, else we pass, okay. Now, for example, we can say that this employee is data analyst if it has at least 4 skills from our list. For example, we can write if length of comparison list is greater than 3, so we return true, else we return false, okay. So run that. So we define, for example, my list one. So let's say, for example, we have R, SQL, and Python, for example. Okay, so we run that, and we call our class. So we define E1 as employee. So we have to put our argument in here. So write my list one. Okay, and we want to know if this employee is data analyst. So is data analyst. Okay, run that. So we have here, okay, I have list return false, right? So it says that it is not data analyst because we only have 3 skills. Okay, for example, if we define my list 2, for example, we write this, and for example we can add here calculus. Okay, so we run that, and we define our employee as 2. Okay, so is E2 data analyst, for example. So we have true. Okay, now we have defined a class of employee, and we have defined a method that says if this employee is data analyst or not. Now we want to create another class that we'll call class senior employee. Class senior employee. Okay, and we will inherit the employee class. So we will have all this in our new class. Okay, so we call employee between the parentheses, and we have to add another parameter, 1 or 2 or 3 parameters. So to do that, we need our constructor. So we write def init. So we call self. We have skills list, and for example we can add experience. Okay, now there is a method that is called super, which is used to get all the methods and the properties from the employee class. Okay, so we write super dot init, and we have skills list. Okay, now we have also to define our new variable, which is experience. So we have another parameter. Okay, now like this we have inherited all the methods and the properties from the employee class. So we want to know if, for example, this employee is a senior data analyst. To do so, we can define another method, call it is senior data analyst. Okay, so we call our self, and we say that if self dot is data analyst, so we call our method, which is data analyst, and we will compare the experience. So if self dot experience, for example, is greater or equal to 5 years, then we print yes, this employee is data analyst, a senior data analyst, for example. So this employee is a senior data analyst. Okay. Else, print, for example, no, this employee is junior data analyst, for example. Okay. No, this employee is a junior data analyst. Okay. So else, so if it is not data analyst, we directly print this employee is not data analyst. Okay, print. So this employee is not data analyst. Okay, so if we run that, now we can use the lists that we have defined in here. For example, we define our employee, so E3 equals to senior employee. Okay, and we write here, for example, our first list, my list 1, and we write here 6. Okay, so if we want to know if this employee is senior data analyst, so is senior data analyst, so it says that this employee is not the data analyst. Okay, because we have compared this comparison list with our skills list. Okay, and it is equals to 3. Okay, so it has directly used this method even though we didn't define it in here. So as we have said, super is used to inherit all the methods and the properties from the parent class. Okay, now if we define another employee, for example E4 equals to, for example, we call that senior employee. Okay, and we call the list number 2. We add here, for example, 4, and we run that. So if we want to know if this is senior data analyst, we can just say that. So since we have 4 years, it says that no, this employee is a junior data analyst. Since we have 4 years of experience, so self dot experience is not greater or equals to 5, and we have the number of, or the length of the comparison is equals to 4. So it is a data analyst, but it is not a senior data analyst. Now if we define another employee, call it E5, and we put here, for example, 7. Okay, and we want to know if this employee is a senior data analyst. So write E5 is senior data analyst. Yes, this employee is a senior data analyst because my list 2 contains 4 skills that are included in our skills list, and we do have years of experience that are greater or equals to 5 since we have 7. So it says that yes, this employee is a senior data analyst. So the idea here is that we defined a child class that has inherited all the properties from employee class, which is in our example, the method, for example, is data analyst. So we don't need to write that again in our class in order to use it. We can only use inheritance and using the super function to inherit all the methods and the properties from our parent class. So this is all for inheritance. I hope that you have learned new things. Thanks for watching and see you in the next one.